we need to find big B or big C next. I am going to ask you to please go in alphabetical order so I don't have to grr when I'm grading your paper, because it ends up getting lots of different answers if you don't go in alphabetical order. When you have a choice to make to either find big B or big C, I am telling you find big B first. Why? Because it comes first alphabetically. Okay, so in order to find big B, we have this handy dandy formula up here that says cosine of big B is equal to all of this stuff with all of these things with all the sides on the other side. Now, we are going to be using a rounded answer, and we know Ms. Craven hates rounded answers in general. But according to the formula, cosine of big B is equal to little a squared plus little c squared minus little b squared all over 2ac. And whether we were to use the law of cosines or the law of sines, which once you have little a here to be approximately 16.9 meters, then you have an angle and the side opposite that angle. And the book actually shows you to switch over to law of sines at this point. The reason that I am telling you not to do that is because the law of sines, funny things happen. Law of cosines doesn't have that same problem because cosine is positive in Q1 and Q4. The Q4 answer is not a possible angle in a triangle. So our rule of thumb or our guide is going to be to, if you start with the law of cosines, end with the law of cosines, because then no funny stuff will happen. I have seen examples where people switch to the law of sines and they get the wrong answer because they didn't look for the second triangle, and the first triangle actually doesn't work. It's not a real triangle. Only the second triangle works. You don't have to worry about any of that. There's only one right triangle, or one correct triangle, I should say, when you're using the law of cosines. Again, if you start with the law of cosines, you need to end with the law of cosines. Okay, so plugging in what we have, again, I know we can't avoid the rounded answer, whether we switched over to the law of sines or just continue with the law of cosines. I know that, and I'm fine with it. So our cosine of big B is equal to our 16.9 squared plus our 40.6 squared minus the 26.5 squared all over 2 times the 16.9 times the 40.6. And you can just type the whole top and then the whole bottom in your calculator. So 16.9 squared plus 40.6 squared minus 26.5 squared is equal to, now you should not be doing any more rounding unless you, until the very end. So cosine of big B is equal to 1231.72 divided by, then we're doing 2 times 16.9 times 40.6, and that is 1372.28. And then we know that this is true if and only if our big B is equal to cosine inverse of this guy, 1231.72 divided by 1372.28. And then we put that whole thing in our calculator. So cosine inverse of 1231.72 divided by 1372.28. Make sure you're in degree mode, and our big B is approximately 26.2 degrees. Side note, the book would probably have you write this in degrees, minutes, seconds notation. It's 26 degrees. It's 9 minutes, 33.41 seconds, 26 degrees, 10 minutes. I'm not going to make you do the degrees, minutes thing on the test. I will only ask for decimal degrees. But I will be looking for both of these things to be on your exam. And then once you have found two more or less exact answers on the third one, I am okay with you doing 180 minus for the other angle, minus the other two. So our big C is the guy that we haven't found yet. So big C is 180 degrees minus our 16 degrees, 21 minutes, minus our 26 degrees, 10 minutes makes a little bit more sense than, and really this is approximate. I should have done a squiggle. So big C is approximately, so 180 minus 16 degrees, 21 minutes minus 26 degrees, 10 minutes is 137 degrees, 29 minutes. Or in decimal degrees, oh shoot. It's 137.5 degrees. So again, the book in this section will probably have you do degrees and minutes when they give you degrees and minutes. I'll only ask for decimal degrees on the test, but we should be able to come up with either one of these guys from our calculator. Okay, now I'm going to pause my video.